Hi, everybody. Welcome to 99% Visible. We're going to wait just a minute or two to let any last few people join in, and then we'll get started. Hey, everybody. Thanks for joining. We're going to wait just one more minute just to make sure we've got everybody here, and then we'll get started. So hold on. Hi, everyone. Thanks for joining us. Welcome to I Have an SLO, Now What? Presented by Alex Hidalgo. My name is Spoons. I'm the CTO at Lightstep, and I'll be moderating today. Today's talk is part of 99% Visible DevOps Reliability, a series of talks about building and operating reliable software applications. I'll talk about what's coming up next in our series at the end of the presentation. But before we get started, a couple of things. Today's talk is being recorded. We'll share a link at the end to anyone who signed up. Speaking of signing up, if you'd like to hear about future talks, please head over to 99%devops.com. And if you're tweeting about today's talk, which I encourage everyone to do, we'd love it if you would use the hashtag 99%visible. So the plan for today, after I finish my little introduction, I'll hand things over to Alex. We've budgeted about 30 or so minutes for his talk, and we'll save some time at the end to answer questions. So please use Zoom's Q&A feature to submit questions along the way. Before we get started, I want to take a second to thank our sponsors. 99% Visible is sponsored by Lightstep, Blameless, CodeFresh, Rollbar, and Noble9. We all know that DevOps is more than tools, but tools like these can be effective ways of kickstarting new DevOps practices within your organization. And of course, whether you're getting started with DevOps or if it's been part of your organization for a long time, it's important to have ways of measuring reliability, which brings me to the subject of today's presentation. I'd like to introduce today's speaker. Today's talk is by Alex Hidalgo. He is a site reliability engineer and the author of Implementing Service Level Objectives. Alex has been a part of SRE teams at a number of organizations, and I'm excited to hear what he has to share today. Again, we'll have some time to answer questions at the end, so please use the Q&A feature. And with that, over to you, Alex.
Awesome. Thanks so much, Spoons. So before we get started, I just wanted to talk a little about who am I? Why should you be listening to me about service level objectives? And so my name is Alex Hidalgo, and after spending time in various parts of the tech industry, including IT and networking and security, I've been a site reliability engineer for approximately the last decade or so. And as many of you probably know, SLOs are at the absolute foundation. They are the bedrock of how site reliability engineering works. And I've fallen fairly deeply in love with them. And I think one of the reasons why is actually because I had such a broad experience outside of SRE and even outside of tech, because there are remarkable parallels between how SLOs work and how customer service works in food service, in sales. So before we actually get started about the primary topic, which is what do I do once you have an SLO? Because this is often a stumbling block for people. I do want to talk a little bit about why we need SLOs in the first place. So we live in a world of services. Everything is a service today. You have platform as a service and infrastructure as a service, monitoring as a service, network as a service, database as a service. And we could go on. And none of that even talks about our favorite acronym here, which is SaaS, which in and of itself can stand for software as a service, or security as a service, or search as a service, or storage as a service. And even if you're not living in a world of as a services, even if you're building stuff in-house, chances are that you've adopted a microservice architecture, which is a setup where you have small services that provide limited functionality, but they are able to bring a service to its whole by talking to other services, which depend on other services, which depend on even more services. So how do we actually get to this? How do we get to a huge and deep hierarchy and mesh of interdependencies and services that talk to other services, whether or not they be cloud vendors or your own services? And I'd like to tell a little story about how this actually organically grows. This is basically how I've seen it happen. So someone has a new idea. They have a new idea for a groundbreaking new web service, and they start writing this app. And as they work on the app, they realize that it needs to be distributed because a single version of this binary just isn't able to handle the traffic that they're now throwing at things. And because this is distributed, you got to bring in some kind of load balancing solution. And as traffic continues to grow, realize that you really need to split the database off. Can't just rely on some kind of in-memory storage or something like that. So now we have a load balancer and a distributed app and a database. And then some people want to add some new features. And very early on, you decided you don't want this to be a monolith. You don't want to deal with one massive code base. You want to embrace a lot of the benefits you can get from a true microservice like architecture. And so you add this new feature on, but you really add it as a separate service. And then you add another feature, which is just another service. And this one talks to both the app as well as the database. And then you add some new services over here, and you realize they're really kind of the same. So you make sure that they're running in the same location. And now you got more stuff talking to the database. So now the database itself has to be replicated, not just for performance, but also for reliability. And then you realize that all these features down here, they're really all so interrelated that it's much better to just stick a proxy service in front of it. This makes it easier for the primary app in the center to kind of just send data over there, and then the proxy can figure out which of these microservices actually needs to be responding to that particular request. And then you realize you need some kind of proxy for outbound requests as well, just make sure they're getting routed across the internet correctly. And then people add a bunch of interrelated features, and then some more features, and all these features talk to each other, all these microservices talk to each other. And now you have this mess and you have no idea what's going on anymore. And now it's almost too late. You're like, aha, I know. We need observability. And that means we need logging. And so now suddenly you're logging everywhere, and you've centralized logging platforms, let you look at these logs, and then you add some metrics, and now you got time series data, and you got numbers flying all over the place, and then you add tracing. And this is all good and well, but what do you actually do with all this? This is information overload. And the most important thing to note is that it may tell you what's happening with these individual microservices. And yeah, you can glean a bit about what's happening with interactions, especially with tracing spans, of course, but they don't really tell you anything about what this service, because this entire diagram is a single service as well, albeit made out of many components. You don't know what this actually looks like to your users. So what do you do? How do you use all this data? How do you use all these logs and all these metrics and all these traces? What do you do with them to figure out how reliable you're being and what your outside users, what your customers actually think of you? And this is where what I've dubbed the reliability stack comes in. So at the bottom, you have SLIs, or service level indicators. And a service level indicator is just any measurements that you use to define how a service is operating. But an SLI is different because it explicitly needs to be measuring how your service is doing from your user's perspective, not yours. All these metrics and logs and things, they can tell you how your service looks to you, but they don't tell you a whole ton about what your service looks like to your users. And because of this, it's often calculated. It's often not just a single metric. It's often not even an aggregate of the same metric for many services. It's often done via a combination of many different things. And next on the stack, you have service level objectives, which are informed by SLIs. And a service level objective, or SLO, it's just a target percentage, really. There's also things like thresholds involved, and we're not going to get way too into this today because we could speak hours just about exactly what SLIs are and what SLOs are and how to define them. But the important part for our introduction here is just, nothing is ever 100% reliable. That's just the truth. If you think something's 100% reliable, you're probably wrong, and you're probably measuring the wrong things. Nothing ever works 100% of the time, and that's just simply true. And what a service level objective lets you do is it lets you pick a more reasonable number instead. And it's not just important to pick a good number here because 100% isn't possible. It's because it's too expensive to even try to get there. Since you'll never reach 100%, you will spend infinite resources trying to get as close as possible. And these resources aren't just financial, they're human too. Think about the response time that you need your engineers to have in order to ensure that something is, let's say, 99.999% reliable. 5 nines like that is about 4 minutes and 32 seconds of potential downtime per year. This actually equals out to less than a second, or just slightly over a second every single day. The response times are just absolutely unreal. So don't even try. Use SLOs to pick a more reasonable target. And then finally, at the top of the reliability stack, we have error budgets. And error budgets are just a way of calculating how well your SLO is performed over some kind of time window. Common ones are calendar months or 30 days or quarters. And in fact, there's no reason to not measure multiple error budgets, so you can talk about how you've performed over the quarter versus the week and things like that. And what error budgets really let you do is they let you have better conversations about how reliable you've been. If you have a good service level indicator that appropriately tells you if you're operating correctly or not from your user perspective, and you have a good SLO target that says, as long as we're being this reliable, we know our users are still happy with us, then error budget numbers let you kind of decide, should we be zigging here instead of zagging? What should we do next? And also, one of the most important parts about error budgets, in my opinion, is they let you convert things into terms that are a little bit easier for humans to understand. Unless you spend all your time in this world, the concept of what 0.1% budget means is very difficult to understand. It's much easier to wrap your head around the concept of 43.2 acceptable bad minutes every 30 days. Now, you also have SLAs, or service level agreements. They're also informed by some kind of SLI. They often have their own error budgets involved. I don't talk about them because they're different. SLOs are for making decisions. SLAs are contractual agreements. Generally, if you violate them, you owe someone some amount of money or credits for your service or things like that. And that involves business people and lawyers and finance, and that's just out of my realm of expertise. So this entire stack, the reason it works, the reason it helps you kind of think about the entire reliability of your service, because that's what it's measuring. It's not measuring the performance of individual microservices. You can use SLOs and SLIs to better understand how your entire multi-component service is operating. And this is important because your service really only has one job, and that's to do what users of the service need it to do. Your users don't care if you have 0 errors in your logs and your metrics say you're perfect and you have, like an incredible amount of uptime from your perspective. If the service is not doing what it needs to do for any particular reason, it's not being reliable. But don't forget, you only need it to do what it needs to do well enough, just the right amount of time. If you spend too much time trying to make things perfect, users won't care because people expect things to fail sometimes. A great example of this is, I like to talk about like Netflix or Hulu, some kind of streaming service. If you go to load a movie, you're fine if it takes a few seconds to buffer. You probably don't mind at all. And even if it buffers for like 20 seconds, like once, you're cool with that. Probably, it may be annoying at that exact moment, but you're not going to abandon the service, most likely. You'll be a little bit upset, but then the movie starts, and as long as it continues to work fine after that, everything's fine. But let's say it took 20 seconds to buffer in order to start a movie every single time. At that point in time, you probably get so annoyed that you want to move on to something else. So you don't want to be too reliable, but you do want to be reliable enough. And all of this can lead to much happier people. Your users will be happier if you take this kind of approach because you're thinking about them first. What you're measuring, SLIs, again, are explicitly measurements of your service from your user's point of view. This doesn't mean they necessarily have to be black box, right? That is to say, they don't necessarily have to be measured from the outside, although it's often a good idea. In the very least, though, it means that you're not just using the metric that's automatically exported via your drop wizard framework that tells you that you have this many errors, right? You need to be measuring things, not just collecting them. And you can end up with happier engineers because instead of setting up a million alerts on dozens of different metrics and whether or not you have enough Kubernetes pods running and things like that, what you can do instead, if you have meaningful SLIs that are powering good SLOs, you only have to page someone, or you only have to make an emergency if you're violating your SLO, if you're running out of your error budget. Fewer pages generally make engineers happier. You'll make your product teams happier because, well, you're now measuring the things they care about. A thing I like to mention a lot is that if you have a well-defined SLI and you put it in front of a product team, they're probably like, aha, that's not an SLI. That's a user journey. And these product managers may very well have documents literally titled user journeys that basically describe your SLIs in just slightly different language. Or if you bring your SLI in front of the business aspect of your organization, they're going to say, aha, yes, I recognize that, but that's not an SLI. That's a key performance indicator or KPI. Chances are you're already kind of thinking all about the same things. And by ensuring that you as the engineers are properly measuring things from an SLO perspective, well, all these people are going to be happier because now product, business, the engineers, and your users, you're measuring what everyone thinks about, what everyone cares about. So cool. Now you have a basic understanding of what the reliability stack looks like and how SLOs work and why we want them in the first place. But now what? What do you actually do with this data once you have it? So the classic example from the original SRE book and also somewhat from the SRE workbook is basically this. You use your error budgets. You say, if we have an error budget surplus, that is, we've not exceeded our quote unquote bad time per month, ship more features. Do whatever you want, right? Just have feature velocity. You're able to just pump stuff out until you exceed your error budget. And once you're out of error budget, you say we halt all feature development, we stop pushing out new features, and we focus on reliability instead. I want people to stop thinking about things this way. I think it's limiting, and I think there's much better stuff that you can do with the data. So let's spend the rest of this talk going over a list of things that you can do with your SLO data. And note here, when I say SLO data, I mean everything from the SLIs to the error budgets, everything that kind of comes along with the reliability stack. And I was probably too harsh a second ago when I said, please stop thinking about using error budgets just to gate feature releases, because the first thing on my list is, well, you can use this data to maintain a balance between shipping new features and focusing on the reliability efforts. Let's go back to the classic example from the SRE book. There's actually nothing wrong with this. I do want to stress it's not the only way to use this data. And I do want to stress that there's potential problems that you can encounter if you're using this. But that doesn't mean it's wrong. It's just that people need to think beyond this one simple example. So there's actually nothing wrong with using this, but you got to be careful. One of the things that I've personally experienced on many different teams is that using this kind of model of you're out of error budget, stop shipping features, focus on reliability work, whatever that even means, you end up with back pressure because the development teams, while the operational teams are working on fixing things, the development teams probably aren't like stopping their work on their project work, on their feature work. And then suddenly you regain your error budget and your error budget policy says, yes, we can release now. Then suddenly you release everything all at once, and then everything just burns out right away again. And you end up with a situation where you can only release new features once every 30 days or whatever your time window looks like. And then all the features are released all at once and you burn all your error budget all at once and you're back to square one. I've actually seen this many times. This is one of the reasons I think that this is potentially a dangerous use of error budgets. So the important part to remember here is just this data is all about having better conversations. Look at your error budget, then have a meeting, then say, what does this actually mean? What does this actually mean for us right now? Having it be a hard and fast rule saying as soon as we're out of error budget, we freeze like the release pipeline or something along those lines. I think it's actually dangerous. Use this data and use the humans that you trust to look at the data and make an more nuanced decision. The next thing you can do with your SLO data is you can determine the focus of your project work. So one of the things to remember is one of the reasons I think it's kind of dangerous to word things as, only ship new features when you have error budget is because reliability improvements are features. Features are not just new ways for your paying customers to be able to interact with your product. Reliability is the most important feature of your service. And it's also important to remember that not everyone owns the code they run. Very often when having discussions about SLOs, in the two SRE books, and even many talks I've given and many talks other people have given, it's always kind of assumed that you have this stereotypical setup where you have a development team and you have an SRE or some kind of operational team, and that you're using SLOs to kind of like push back and forth and try to maintain a proper balance. And, but it all assumes that you can change things about the code involved. And that's just not true. I mean, think about open source software and think about how much of it you probably use in your organization today. Every database you use is probably not written in-house. All your caching layers, if you use Envoy, Kubernetes, if you have the Elk stack for your logs, Prometheus for your metrics, these are all open source projects. And if you need to fix the reliability of these services, well, you can't just go fix the code, or, well, you could, but I generally don't think it's a great idea to randomly fork these kind of well-maintained projects. But what you can use your error budget for is to figure out how to fix these things anyway. So it doesn't have to be going in and fixing the code, but you can upgrade versions, or you can introduce the caching layer in front of the database in the first place, or maybe you can make it better distributed. And there's a lot of stuff that you can do to make this stuff more reliable. I just think it's important that when we're having these conversations about how to use your SLO data, that we're not just talking about services whose code you control. And it's also important to remember that developing SLOs in the first place is project work. Figuring out how to calculate SLIs, whether it's for the first time or improving on them, that is project work. And so is picking the correct SLO thresholds. And don't forget that you should be examining your measurements often, and you should be using it to drive your project work to decide, should we tackle X first before Y? But also remember, when you're looking at your measurements, they could be very wrong. They could be off for many reasons. You could have had a black swan event. You could have just been measuring things incorrectly in the first place. Maybe a metric name got changed under the hood and you didn't even realize it, so you're not collecting it anymore, or your aggregation stopped working. The point, again, is kind of like my objection to always freezing your release pipeline just because you're out of error budget. My point here is that these need to be data points you use to look at things and have discussions and have conversations and use that to make reasonable decisions. Using them as hard and fast rules can be a problem. Nothing is ever perfect is one of the primary tenets of an SLO-based approach, and that means your measurements aren't going to be perfect either. The third thing you can do with this kind of data is you can more easily examine your risk factors. So error budget burn lets you better identify when you're not being reliable, even for short windows. It may be easy to spot when you're unavailable, but that's not what reliability means. Availability is certainly an aspect of reliability, but they're very different things. If you remember from a little earlier in the talk, we defined reliability as your service doing what its users need it to do. And availability is a certain part of it, but there's so much else going on. So error budgets let you notice when you have individual little misses. Maybe things were bad for 30 seconds here, or maybe you just had 3 bad events out of 60,000. And maybe sometimes this isn't important data, but maybe sometimes it is. If you notice that you're burning error budget somewhere, even at a very slow rate, even if you're never going to exhaust it, you can still figure out what's causing that in the first place. And it could be that it's not important. It could be that you do nothing there, but it could be that you're uncovering something that you could prevent from snowballing into a bigger problem. And just kind of looking at your error budget burn and your SLO status, it generally just allows you to determine what your risks are. If you burn a certain percentage of error budget every time you perform a new release, for example, maybe that means you need to shore up your release process. And you may have never noticed that before, because this may not have caused unavailability, and it may not have caused customers to necessarily complain, but if you're causing them headaches every single time you perform a release, maybe it's a place to look at. Again, though, be reasonable. Maybe it doesn't matter at all. The point is just that you have better data points now to have better discussions. Other things that could be causing you problems are DDoS attacks, that even though you think your infrastructure or your CDN is picking up on them very quickly, maybe it's actually causing more of an outage until they pick up on things than you realize. Maybe hardware upgrades are routinely causing you problems, and again, you just hadn't realized it because, well, maybe all the services that you're running internally, they look fine, but things don't look great from your user perspective. There's all sorts of stuff here, and the point is just because error budgets give you a more holistic reliability view over time than, say, just an availability metric or something along those lines, they can let you better understand what is causing you a problem and when. The fourth thing you can use error budgets and just SLO data in general, I should be saying, is to either justify experimentation or delay that experimentation. So any kind of experimentation can potentially break your service. And I actually think that breaking your service on purpose is awesome, and people should be doing it more often. And when I say break your service, I don't mean availability. I don't mean that you're necessarily taking it down, but some amount of error injection. What do things look like if I make this service, make that API call via that method instead of this other one? These are all great things because they may not work as you expect, or they may work better. This is awesome data to have, but it's important to probably not be too cavalier about this if you haven't been running reliable from your user's perspective recently. And error budgets let you know this. They let you say, okay, over the last 30 days or last quarter, how reliable have we been? And you can look at that number. And again, this is all about better data to have better conversations. And you can now say, all right, we want to perform this experimentation, but we're pretty sure these numbers are accurate. And we've been operating kind of shitty for our users for a while now. So let's let that either drift into history or actually focus efforts on ensuring that doesn't happen again. But either way, maybe we don't experiment right now. And this is just another great example. This is how you use SLO data and error budgets. They just give you a better data point to have the discussions about what should we be doing right now. But not only can these kind of numbers help you figure out, should we be performing experimentation in the first place? It can also tell you when you start to break. If your error budget is fine and you have a surplus and you think your users would be fine with a potential little bit of unreliability in case one of these experiments goes sideways and it doesn't quite work the way you think you do, well, all these measurements tell you this. All these measurements tell you when are you going to start missing your SLO targets with these changes that you've introduced. So it's not just about proper planning. And I also want to capture that, this talk cannot talk about experimentation and chaos engineering in general in any kind of real depth, but this doesn't have to be anything complicated. Experimentation could be anything like, do you just want to try a new algorithm? Have you always wondered what happened if you use a different garbage collection method for your JVMs? Well, but give it a shot, try it. If you have enough error budget, as long as you have a good rollback process, of course, if you have enough error budget, just give it a shot. Who knows? Maybe you run better. Maybe you run the same. Maybe you run worse. But error budgets give you a good number to look at to say, should we try this right now? I've always been curious. What if we change our cache retention configuration? Will things actually operate better? Who knows? Use your SLO data to help you have conversations with every team that needs to be involved to say, should we give this a try right now? The fifth thing is you can do things like schedule load tests, stress tests, black hole exercises where you shut off one of your data centers or something similar. And these are actually pretty similar to experiments, but I think they often have a more concrete goal involved. Experiments are often like, who knows what will happen? Things like load tests and stress tests are often, they have a goal. Where on the curve does stuff break? When we turn things up, whether or not it's via more traffic or traffic that's more difficult to compute, when does stuff break? And so that's kind of the difference, I think. That's why I list these as two separate things you can do with your SLO data. It's because experiments are often done by individual teams, but load tests, stress tests, black hole exercises, they generally require coordination across many, many different teams. But this is a great example of why you need SLOs for multi-component services. Because chances are you don't have a single metric from a single binary running somewhere that actually tells you how things look when you place your entire customer-facing service under a load test. You need some kind of aggregate. You need some better measurements to let you know how things actually look when you run these kind of tests. And just like with experimentation and chaos engineering and things along those lines, this isn't just about using this data to say, yes, we should be running this black hole right now versus no, maybe we got to wait a quarter before we run one of those. It also tells you if you do run these tests, when you do have good error budget, when do we start burning it? When do we start missing our SLO targets? This gives you a good idea of, you don't just want to perform a load test and ramp it up until all your binaries are crashing. That's not a very useful bit of data, actually. A much more interesting bit of data is where, as we're ramping this up, do we start to miss SLO? Where do we, according to our measurements, start being unreliable for our customers? That's a much more interesting piece of data. So again, just like experiments, it's not just about planning when you can do them, it's about better examining the results of these tests when you perform them. Number 6, you can just turn stuff down. So there's this famous story about Chubby at Google, and I was at Google for a long time, so I can confirm this absolutely happens, or at least happened. Been gone a few years, maybe things have changed, but for a long time, so Chubby is a global lock serve service, and it just basically lets you store tiny bits of data that a lot of services use upon startup to discover the current leader in their cluster, just little things like that. Just a way to load little bits of data that you can ensure are propagated and similar, if not equivalent, across many different clusters and things like that. And although global Chubby does exist, and this means it's literally available from every single data center Google has, it's actually pretty well documented. You're not supposed to rely on global Chubby. It's just something there as a convenience. If you need reliance on Chubby, you're supposed to be reliant on the local versions running in your local cell. But Chubby is a very old service, and it was very well maintained, and it didn't often see changes to the code or anything like that. So even though Chubby had a high number of nines, a very stringent SLO target, at the end of every quarter, they probably still had it remaining because, or they still had their error budget remaining, I should say, because global Chubby just ran well. It did what it was supposed to do. So they turned it off. They would tell people this wasn't done entirely under cloak and night. An email would be sent out, hey, this Thursday at 2 p.m. Eastern, we're going to shut off global Chubby and burn the rest of our error budget, which is only a few minutes. And even though people were warned about this, and even though it was heavily documented that you could not or you should not have a hard dependency on this service, they burned their error budget by literally shutting things off, and people would break every single time. And this is actually cool because it allowed people to learn. It allowed people to learn about hard dependencies that they didn't realize they had. So this is pretty advanced to get to because leadership is not always super keen on the concept of a team just shutting off their service, but it's a great way to learn about how services interact. And I would even say that, if you have the right cultural buy-in, you can just do this. I think it was very nice of the Chubby team to email out, but I don't know, if you're pretty sure you're not going to completely take your entire, company's service down, if you're just a small microservice in the back of the stack that might break one feature by going down for a bit, do it. It can be part of your sprint work. The 7th thing I want to talk about is doing nothing, absolutely nothing. I think this is actually one of the more important things that we should be talking about today. People spend a lot of time setting up their SLIs and picking their SLO targets and their error budget windows, but sometimes the numbers are just wrong. Or sometimes you already know you have a problem. You can't always fix something. It's not always a single bug. Sometimes it takes long architectural changes. Sometimes it can take months and months, if not quarters. Maybe you're waiting on the delivery of a whole bunch of new hardware or approval from finance to turn up in another cloud region. Or, you can have weekly meetings and you can ensure that every week you're looking at your numbers. And sometimes just ignore them because you already know things are bad. Or maybe you had a black swan event, right? You have something that you're fairly certain is not going to just reoccur out of the blue. So, okay, yeah, our numbers look terrible. We burned through all of our error budget and 6 extra hours of it. And that sucks for like our dashboards that show these numbers, but that doesn't mean you have to do anything at all. The point is to have this data available to have these discussions. And one of the results of these conversations could just be don't do anything. Just to remind everyone, it's the third or fourth time I've said this, but SLOs, they're data. They're data you can use to have conversations. They're not mandates. And number 8, one of my favorite, you can report in your service in a more meaningful way. So reliability reporting. How do you determine reliability, especially of a multi-component service and especially of a customer-facing one? How do you determine reliability over time? The 2 most common I see are things like incident counting and MTTX, mean time to R recovery, mean time to D detection. We'll talk more about that in just a second. But we can use some pretty simple math that shows that these are both kind of incorrect methods to use. So the problem with counting incidents is, let's say in Q1 you had 20 incidents, and in Q2 you had 10 incidents. If you're just counting incidents and you have an OKR that says we need fewer incidents, well, that doesn't actually make your users happy, because perhaps in Q1 you were unreliable for about 120 minutes of time, and in Q2 you were unreliable for about 150 minutes of time. Now, if you're just counting incidents and your OKRs and your goals are just to reduce the number of incidents you have, well, this would seem to imply that Q2 is better because 10 is fewer than 20, but Q2 had more total unreliability time. So then the next most often thing I see people do is they say, okay, it's not about the number of incidents we have, it's about how long they run on average. So this is where people start introducing MTTX. Now, what is this? It stands for so many things that I would not be able to put it on a single slide. I have a list in the book actually that takes up an entire page of just things I've actually seen out in the wild. Some of the most common ones are things like mean time to resolution or remediation or recovery or response. You see how many of these even just start with the letter R. And the idea here is this is how long it takes for our incidents to resolve. And if we look at the mean time to recovery over a quarter, now we understand how we've actually operated over time. But you'll see things like mean time to failure, mean time to detection, mean time to engagement. Again, there are dozens of these. And that's actually, in my opinion, one of the problems there too. You can almost never be sure that you know what other people are talking about because so many of these share the same letters. And do we care about detection or do we care about engagements? Do we care about when someone got paged? Do we care when our automated system found out? Do we care when the page was delivered or when the on-call engineer got in front of their laptop? Or there's so many different nuances here that don't allow this data to actually have much of a meaning. Everyone's going to have a slightly different view of exactly where to start measuring things, but you could end up with drastically different numbers, especially over the course of, let's say, an entire quarter or an entire year or whatever your reporting cadence looks like. So let's use the exact same numbers from before. In Q2, you had 20 incidents totaling 120 minutes of unreliability, and in Q2, you had 10 incidents totaling 150 minutes of unreliability. This shows that in Q1, incidents were an average of 6 minutes each, and in Q2, incidents were about 15 minutes each. Now, in this case, at least we've identified the correct quarter. Things were, in fact, worse in Q2 than they were in Q1 in terms of our customer's viewpoint, in terms of total amount of time in minutes of unreliability. But Q2 was not more than twice as bad as Q1. 15 is more than twice 6. So again, you're kind of being misled here. So even if you get a very comprehensive definition of this is exactly what we mean with mean time to detection, and this is exactly what we mean with mean time to failure and recovery, and everyone's on board for exactly how this is measured, simple math can still just lead you down the wrong path. So just use error budgets. This is literally what they're designed for. They're ways of telling you how reliable you've been over time. This is a much better way. This is how you can find out, oh, that was 120 minutes, or oh, that was 150 minutes. Especially because error budgets will capture times that you're unreliable, even if it wasn't enough for you to have a quote unquote incident. Incident counting and MTTX almost always involves the concept of someone getting paged, almost always involves the concept of, having an incident retrospective and an official document and, reporting this up your management chain and things like that. And that's all cool. And I hope we can learn a lot from that kind of process. But those are not the only times that you're being unreliable. There are plenty of other little times that you may not otherwise know about, or are not lengthy enough to trigger a page. And sure, you could go back and add this and try to finagle your incident count to handle it, or your mean time, whatever. But why? You have a tool here. You have error budgets. Use them. And what's great too is, like, even if you use error budgets on your team to have a discussion over a 30-day window, let's say, to figure out whether or not maybe we need to pivot this or delay this project or do this other thing instead, you can go back and calculate error budgets over any period of time, week, month, quarter, year, whatever's best for the reporting needs of your organization. And finally, it's just about having better conversations leading to better decisions. And that's the most important. Like, it's not even maybe, I should take that word out. Because this list is all just examples. Everything I've talked about today, they're all examples of having better conversations that hopefully lead to better human-based, data-driven decisions. Every single thing on this list before this slide is really just part of this slide. It's data. They're not mandates. The most important part of all this is actually just SLIs. The most important part of an entire SLO-based approach to reliability isn't even SLOs at all. It's SLIs. It's about having measurements that meaningfully measure your service in terms of your user's perspective. Things like SLOs and error budgets, they're just some pre-done math that make it easier to look at the numbers, that make it easier to have these decisions, or have these conversations and make these decisions. But it's the root of all of it. It's service level indicators that actually matter. Take a step back, measure things from your user's perspective. Use SLOs and error budgets to provide you with some pre-done math, so you don't have to break out, paper and pencil and figure stuff out. But just use this data to ensure that your team or your organization or your leadership, whoever it needs to be, has better data in front of them to know, here's how we've looked and here's how we want to look moving into the future. I would be remiss to mention that I wrote a whole book about this. I'm incredibly proud of it. It's not just me. I wrote about half of it, and the other half is written by many brilliant people from across the entire industry. It's literally at the printers, so copies should start shipping in the next few weeks. An e-reader copy is available now, but honestly, I don't love the formatting of it. There are a lot of charts, a lot of equations that I just don't love in the Kindle view, but if you're chomping at the bit, you can pick it up there now, or pre-order your physical copy, and those should show up pretty soon. And that's all I got for you. Would love, I see there's quite a few questions already, and love to spend, well, we have 15 minutes left. Hopefully we can get through a lot of them.
Yeah, we can try. Well, awesome, Alex. This was great. Thank you. So yeah, looking at the questions a little bit, one of them, man, there are so many of them. One of them kind of was started early in the process, like thinking about like what is the right time in an organization to start thinking about SLOs. I guess both in terms of the organization and maybe in terms of a project life cycle as well.
Yeah, so I think it's incredibly important, if possible, to build in this kind of thinking during the design phase. I mentioned that it can be difficult to have the right metrics available to you, for example. You often have to build entirely new services, in my experience, to actually do the right calculations for you, often because your services were not built to ensure that they were emitting the right data that you need to measure things from your user's perspective. So if possible, start this at the actual design phase. Put this, like in your design doc. If you have a design doc template, add an SLOs section. So talking about it in that sense, I think that's part one. Absolutely. If you're able to start thinking about it as early as possible, it's much easier to start with this than to try to bootstrap it later and kind of put things into place later. So that's one. Two, if you're talking about an existing organization with many existing products and perhaps many existing services, it can be difficult to figure out how to get started. And for that, I've had the best success both with myself and with just other, like other people I've witnessed. It's easiest to just have someone get started on it, and that can hopefully show how this works, and hopefully you're happy with the process, and this can be a great data point for other teams to look at, be like, maybe we should be working on SLOs as well.
Yeah, one of the other questions was how to sell SLOs to an old school enterprise company decision maker, saying they pretty much only care about cutting infrastructure cost and see infrastructure just as a cost center. Mm-hmm. Maybe part of what you're saying is part of the answer to that question, but how would someone go about convincing someone who's maybe not a decision maker who's hasn't used SLOs before?
Yeah, that's not always easy, but I think there's two approaches here. One is, again, you can just start. Chances are, unless you live in a very regimented company that won't allow your own team to make the decision to measure your own service in your own way, chances are you can just start and then show these numbers and explain to people that this is working for us. Maybe we should be trying this at a more company-wide level. Two, the other thing is I actually feel like SLOs are a cost-saving measure. Most of the time they help you do better math to figure out how you're actually running. And that doesn't mean you always have to spend more money, because one of the basic tenets of SLOs is picking the right amount of reliability and trying to aim for 100%. The objections you generally get from people who don't buy into SLOs, especially at the leadership level, is almost always certainly like, no, we should be striving for 100%, or we should be trying to get as close as possible. But there's very simple math and very simple, examples we can use from other engineering disciplines. I think it's maybe one of the most important parts is to have these conversations. You're like, this isn't something, reliability engineering has existed for decades and decades and decades, right? And there are lessons we can learn from that. And let's stop as a tech industry, like trying to invent our own processes everywhere. And if other engineers, if the ones that build bridges in the International Space Station, if they acknowledge that things fail sometimes, they understand that 100% is impossible. We certainly, as software engineers, should also be able to understand that 100% is impossible. And I think that's important just because that's a good way to help convince, like, okay, you leadership, you're worried about costs. Well, you're going to spend so much money trying to get to 100%. In fact, you're going to run out of money before you can ever get there.
Yeah, cool. Yeah, I mean, you can think about like over provisioning as an example, right? Like you may have over provisioned in order to try and hit 100%, but if you don't need to, that's money you can save, right?
Yeah, I didn't talk about it tons, just it wasn't an example that came up, like in my talk, but absolutely use these numbers. Again, they're just numbers to have better conversations. And if you look at it and be like, well, our customers, we're pretty sure they're happy if we're 99.9% reliable, but we've been 99.99 for a while here. We don't need to be that reliable. Maybe we can turn half this stuff off and still be absolutely fine.
Yeah. A couple of questions about determining the SLIs. So I think maybe two angles on this. One, do you formulate the SLOs and SLIs as an SRE team? Do you work with dev teams, product owners, businesses? And then maybe part two of this, which I can remind you about, is thinking about, is there a different approach in thinking about SLOs and SLIs for a product team versus an infrastructure team?
Yeah, let me answer I guess the first one first. The most important part of figuring out your SLIs, it's very simple to say, just measure from your user's perspective, but it can be difficult to figure out what that even means. And you're never going to get there either, right? Like, I guess hypothetically, if you had a perfect non-sampled basis of collecting every single trace, and you had your traces set up from like your user's browser all the way to the database and all the way back, right? An essentially unattainable thing. Then maybe you could say we're actually measuring things from a user perspective because you have every bit of data of every single user interacting with you, which would catch things like, problems with their consumer grade internet, which, impacts how reliable they view you, even if you don't realize it. But so it's easy to say, think about your users. It's very difficult to get there. I totally get that. But I think the best approach is to enter with the understanding of you're trying to get as close as possible. You're never going to get all the way there. And two, just stop thinking reliability as anything beyond what your users need. People often conflate reliability and availability, and those are totally different stories. You need to be available, but you also need to be responding quickly enough. So you care about latency. You need to be responding with enough good responses. So you care about error rates, but you also need to be responding with the correct data. So you care about data integrity, and you don't need to be responding with the correct data. You got to be responding with the data actually being asked for. Like, you want today's data, not yesterday's. So now you're concerned with data freshness, and it's a lot of stuff. It's not easy, but that's also why I mentioned several times in this talk that, SLIs are actually the most important part. If you never get to an SLO target and error budgets that you're using, it's fine. Just spend more time thinking about how to measure things from your user's perspective and try to get as close as possible.
Yeah, and then thinking about from the perspective of a product team versus an infrastructure team, is there a difference there?
I think not. Something, again, didn't quite have time to get into this talk, but I often talk about the perspective of your users, but I generally have kind of a sidebar that explains what do I mean when I say users, and I mean anything that interacts with your service. It could be a paying customer, it could be another internal engineer, it could be just a microservice. It could be a microservice that's 7 layers removed from an actual human. It could be a customer paying to hit your API. It could be a robot. It could be, it's simpler to say user instead of having the qualification of all those things all the time. Your approaches in infrastructure to making things more reliable will likely be different than product, because in product, again, you probably own the code base. In infrastructure, you very often don't. So perhaps how to make things better might be different. The exact project work decisions that you may make based upon these numbers may look very different. But thinking about how to measure it, I think, is the same, as long as you're able to wrap your head around that user doesn't just mean human. It means anything talking to your service.
Yeah, I'm with you. I also qualify that all the time. Users, internal and external, right? But I wonder, just from your experience, like the communication channels you have with other people within your organization are totally different than the ones that you have externally, right? So does that change like how you go about setting them in some way?
I think it can, absolutely, because for internal services, especially infrastructure-based ones, it's easier to find out what SLOs these other components have, which makes it better to figure out what your SLO should be, because you can't really be more reliable than something you have a hard dependency on. Way too much to say about all that.
Sure.
Time remaining, of course. So yeah, you do. I think the biggest difference is that infrastructure targets need to be much stricter, because the product is going to end up relying on all of that infrastructure, and your product is likely not going to be anywhere near as reliable from a number of nines perspective. But like, that's totally fine. I do think it's important to figure out how to have interviews with your users, and now I'm talking about actual external customers.
Mm-hmm.
You need to figure out not just how you think they're experiencing your service, but how they're actually experiencing your service. Surveys are bad. People either don't fill them out, or if they do, they just pick 1, 5, 1, 5, good, bad, good, bad. Interviews are expensive and difficult. They're not just expensive for you as a company, they're expensive for your users, because how often will they really want to sit down with you for an hour? So I do also recommend having, like, give them a gift card or like whatever, like whatever you can. But that's actually a very important way to find out how people actually feel about you, because you want to know before your subscription numbers go down.
Yeah. Okay, maybe shifting a little bit and thinking, okay, we've had those conversations. A couple of the questions are kind of about getting into the specifics of choosing those SLIs, or maybe even, and maybe this is where some examples can help, but like how many SLIs should my team have that are part of these SLOs, and how do maybe I have a lot of metrics, I've got 27 endpoints that I manage. They're all unique and special. I don't know, maybe you could give some examples of kind of pulling those different kinds of metrics data together to form, a small number of SLIs.
Yeah, so the example I like to use there, and this is much simpler than 27 different like endpoints, but as an example, maybe you don't need an SLI for both cache hit rate and cache hit latency and cache miss latency. You probably just want overall latency calling to your service. You do want to be collecting metrics on both cache hit latency and cache miss latency, so that if your SLI says, okay, we're now performing worse than we should be, according to what we believe our users need, that you can then go look at those metrics and figure out where the problem is. But just make sure you're trying to capture, you can capture multiple things with a single measurement, right? In my example, you're again capturing cache hit and cache miss latency. And then you can go look at which one of those is causing you problems if you're burning error budget there. You can do a similar thing with API endpoints. You can aggregate them all together. Or if they do very, very different things and run through totally different code paths, then maybe you do need a few. It's almost a kind of cop-out answer, but too much of it depends on your service. The important part, again, said it a million times, take a step back. What do your users need from you? Try to figure out what that is. Try to get as close as possible, but always be reasonable. Having 27 SLOs is not good, right? With too many collections, what's that paradox called? I'm not going to remember the name right now, but if you collect too much stuff, not only is there a greater chance of outliers popping up, but you as the human will always assume you're spotting outliers that aren't even mathematical outliers. When you have too many things to look at, you get lost in the data. So try not to have too many. I don't know what the exact answer is. The Google SRE books used to say 5 or 6. I don't care about giving someone a number, to be honest. It's just always be reasonable. This is about collecting data for your team to have better insights and make better data-driven decisions. It's not about covering every single endpoint. It's about, are we collecting enough data that we know when we're operating reliably or not for our users? Again, whether or not that user just be another internal microservice or actual paying customers.
Yep. Let's see, I think we have time for maybe one or two. I'm just trying to see if I can pull some themes out of the questions here. One question that came up was SLOs for non-production environments, like a staging or load test. Is that something that you've seen people do or recommend?
Yes, with the caveat that you generally don't act on it. Right? Like you definitely don't want to be paging on error budget burn rate in your staging environment, but it might still be useful to have that because it can still help predict perhaps. Like I'm actually a fan of not having a staging environment, but I understand most organizations, still do. I love just testing everything in production. Just use very careful canarying instead. But if you do have a staging environment, sure, like measure it the same way you measure your production environment, but you probably don't want to care about the numbers in the same way. Like as with everything else, be reasonable. I've seen some people do it. I don't for my current services. Like for example, there's 0 SLOs outside of anything I manage that isn't in production. But if you want to, that's fine. Just make sure you're not causing yourself extra headaches by doing so.
Yeah. Okay. You said 5 or 6 is what the Google SRE book says for the number of SLOs. Is that per service? And how does this sort of work as you scale up? Maybe it's fine for we got 5 services, but now we've got 500.
Right. But that's why I don't like these recommendations, because it's too dependent on your actual service. Service, what is a service? The example I often go back to is a retail website, right? Like a retail website has a shopping cart microservice and a payment gateway microservice and a search microservice, and probably something that helps deliver images from some kind of image store or the cloud or whatever. And those are all services. But the retail website as a whole is a service as well, but it's made up of all these other services. And, what if you run 2 different retail websites for the same company? Is all of that one service too? Maybe, I don't know. That's why I don't like giving these complicated answers, because what is a service is a very complicated question in and of itself. As always, be reasonable. Do this to make your lives easier and your customers' lives better, your users' lives better. If you could go down a million rabbit holes trying to figure this out exactly, and that's why I don't love those recommendations. Measure what you need. Maybe your service is super simple, and all you actually need is error rates, right? Yeah. Maybe that's all you actually need. That's fine too. You don't have to make it more complex than it has to be.
I guess maybe one way of just setting people's expectations, would you expect the number of SLOs in an org to grow like linearly with the size of that organization, or should it actually not explode in that way?
I think if you are a organization that supports a common product, then perhaps you should not be exploding linearly, because you should be doing more measurement of the entire product itself as opposed to every single individual microservice underneath it. But if all these services are really truly distinct, then maybe they would grow. So again, not trying to cop out, but it's so dependent on what this organization looks like, what these services look like, what these multi-component services look like, et cetera, et cetera. I would say if you're seeing exponential growth with over a linear curve of services, then perhaps things are starting to spiral out of control.
Yeah. Cool. Well, thanks, Alex. This is a great presentation. That's all the time we have for questions today. Before everyone takes off, I wanted to just say a few other things. So you've been watching 99% Visible DevOps Reliability, a series of talks about building and operating reliable software applications. I wanted to let everyone know that our next talk, which I'm really excited about, comes up in about a month on September 17th. We're going to have a presentation by Luis Minero about doing dynamic page routing called "Are We All on the Same Page? Let's Fix That." And if you sign up for today's talk, you'll be getting an email that tells you how to register for that. If you don't, you can also go to 99percentdevops.com and do that. We're doing a book raffle as part of today's session to give away copies of Alex's book, and we're going to be doing that drawing shortly, and the winners will be hearing from us over the next couple of days. 99% Visible is brought to you by Lightstep, Blameless, CodeFresh, Rollbar, and Noble9. That's all we've got for today. Thanks again, and I'll talk to you soon.